Hello everyone, good evening. So here we shall solve some more JEE Mains previous year questions on the chapter Electrostatics. So any doubts if you have in any steps, then please write that in the comments. We shall obviously clarify them in the subsequent videos. And also in any other chapter of physics, if you have more difficulty, then please mention the name of that chapter also in the comments section so that we can give more priority on it and solve more and more questions on that chapter. And also please install our Sapience education application whose link has been provided in the description. And here it is told the first statement is an electric dipole is placed at the center of a hollow sphere. So there is a hollow sphere at the center, an electric dipole is placed. The flux of the electric field through the sphere is zero. Obviously the flux will be zero only since the net charge enclosed is zero only. So if we apply the Gauss law, then, then the electric flux is given as Q enclosed by epsilon naught. Now since enclosed charge is zero, so the flux also will be zero. But the electric field is not zero anywhere in the sphere. So anywhere in the sphere, the electric field will not be zero. And then here it is told that only at the center of the sphere, okay, placed at the center. If R is the radius of a solid metallic sphere and Q be the, or in a metallic sphere, they have taken one metallic sphere. So then if R is the radius and Q is the charge on it, the electric field at any point on the spherical surface of radius R, R less than R is zero. Since why it is a metallic sphere, so it is a pure conductor. So hence all the charge will reside only on the surface of the sphere, and there is no charge inside the sphere. So inside, if we apply the Gauss law, then we will have no net charge inside. So hence the electric field also will be zero inside the sphere. It means for R less than R, the electric field will be zero only. But the electric flux passing through this closed spherical surface of radius R is not zero, but the electric flux passing through this closed spherical surface, the electric flux also will be zero only. The electric flux will be zero only since why there is no net charge enclosed within this sphere of radius R. So it means statement 2 is false. So statement 1 is true and statement 2 is false. So option C is the correct answer. Here it is told an inclined plane making an angle 30 degree with the horizontal is placed in a uniform horizontal electric field of 200 Newton per Coulomb as shown in the figure. A body of mass 1 kg and charge 5 millicoulomb is allowed to slide down from rest a height of 1 meter. So at a height of 1 meter it is placed and 5 millicoulomb is the charge on it. So the charge on it, that is 5 into 10 power minus 3 coulomb, and the mass is 1 kg, and slide down from rest at a height of 1 meter. If the coefficient of friction is 0.2, so the coefficient of friction is 0.2, then find the time taken by the body to reach the bottom of the inclined plane. G is 9.8 meter per second square, sin 30 is half, cos 30 is root 3 by 2. So therefore Now, so it will have some. So the net force on this mass we have to find. So this mass is kept on an inclined plane. So mg is acting downwards, and this is angle theta. So this will be mg cos theta. This will be angle theta. So mg cos theta, and this will be the normal reaction. There is a friction also, and like this, the charge q into E is the electric force acting, where q is 5 millicoulomb. So this is QE. So say this is angle theta also. So therefore its component will be QE cos theta like this, and this will be QE sin theta. And there is friction also. So friction is acting. So like this, there is mg sin theta acting, and this way the frictional force is acting. Frictional force, which is E times n. Now therefore the acceleration we have to find out. Now the net force, so it is accelerating downwards, so I can say ma, the net force, that is the net force downwards, that is down the incline, so it is mg sin theta minus qe cos theta, and then n will be equal to mg cos theta plus qe sin theta plus qe sin theta. So now the frictional force, that will be equal to mu times n, which is equal to mu into mg cos theta plus qe sin theta. So now so ma, that is mg sin theta minus k cos theta minus the friction, which is mu n. So then from here we can find out the acceleration. And when we will find the acceleration, then we can say the length, the height is 1 meter. So therefore we can say if the length of the inclined plane is suppose L, then we can say L sine 30 degree, L sine 30, that is equal to 1, which is the height. So L by 2, that is h. So L will be equal to 2 times of h, that is equal to 2 meter. So now we can say L, that will be equal to half at square, since it is allowed to slide down from rest. So initially it was at rest only. U is equal to 0. The initial velocity was 0 only. So it is half at square. L is equal to half at square. Now L, that is 2 meter. So now this time we have to find the time taken by the body to reach the bottom of the inclined plane. So T will be equal to root over 2L by A. L by A, which is root over 2 into 2 meter by A, which is 2 by root A. Now acceleration we have to find. So ma acceleration, that is mg sin theta minus qe cos theta minus mu times mu mg cos theta minus mu into qe sin theta. So therefore the acceleration, that will be 1 by m, mass is 1 kg. So mass is 1 kg only. So A will be equal to g, that is g sin 30, g sin 30, that is half, minus qe, that is 5 into 10 power minus 3 qe cos theta. E is electric field is 200 Newton per coulomb. Electric field is 200 Newton per coulomb. So therefore E and cos theta, that is 3 by 2 minus mu is 0 0.2, 0 0.2, and mass is 1, g 9.8, g that is into cos theta, that is root 3 by 2, minus mu, that is q, that is 5 into 10 power minus 3, into e, that is 200, into sine theta. Sine theta, that is half. Sine theta is half. Now this will be 100. This is 0 0.1. This is 100. So acceleration, that will be equal to g by 2 minus, this is 0 0.5, 10 power minus 1, this will be, so root 3 minus root 3 by 2 minus, this is by 10, so g root 3 by 10 minus, this is 2, 5 to z 10, that is 1 minus 3, this is 0 0.1, it's 1 by 10. So therefore the acceleration, that will be equal to g by 2, that is 9.8 by 2, that is 4.9, minus root 3 by 2 minus root 3 into g by 10, that is 0 0.98 minus 0 0.1. So this is the acceleration. So therefore the time taken, that we have found, that is 2 by root a. Now therefore 2 by root over this, we have to find out. It is 4.9 minus, this is 1.73 divided by 2, that is 1.73. 3 is approximately 1.732 divided by 2. So that is 0 0.28 is a 16. 6 are 12, 6 is 12, 0 0.87 approx. Minus, this is 0 0.98 into root 3 minus 0 0.1 plus root 3 into 0 0.98. So this will be how much? This will be 1.7 approx. This is 4.9 minus, this is 0 0.77 minus 1.7. So this will be 4.9 minus 7. That is approximately 4.9 minus, so that is 2.43 approx. So it is root over 2.43. 2 by root over 2.43. 1.56. So it is 2 by approximately 1.56. So it is approximately, so it is 1.28 seconds. 1.28 seconds means approximately 1.3 seconds. So the time taken by the body to reach the bottom of the inclined plane is 1.3 seconds. So option C is the correct answer. And here it is told, find the electric field at point P as shown in the figure on the perpendicular bisector of a uniform charge thin wire of length L carrying a charge Q. So it carries a charge Q. The distance of the point P, the distance of the point P center of the rod is root 3 by 2 L. Distance of the point P from the center of the rod is equals to PL by 2. Find the electric field at the point P. Okay. So it is having uniform charge. So now, as you know, that if we have a uniform thin wire, then if this part makes an angle theta 1, this end makes an angle theta 1 and theta 2 with this point, then you can find the electric field at this point. How? If it is having lambda is a charge per unit length, which is Q by L. So then we can say here, we will take a small line element dq. So it will exert an electric field dE here at the point P. Now we can take its components. Suppose this line element makes an angle theta with the x-axis. So then this is suppose the y-axis. So then dq I can say it is equal to actually lambda dy. This is dE cos theta. This is dE sin theta. D sin theta. So then we can find the x component of the net electric field. So that will be integral dE cos theta, where theta will go from minus theta 1 to plus theta 2. Now dE I can say that is equal to obviously k dq by r square. Now this is, so suppose r, k dq by r square. So then if I take this is length x, so then r is actually x by cos theta. X is r cos theta, so x sec theta enter. And also y is equal to x tan theta. That's why y by x is tan theta. So y is x tan theta. So dy will be x secant square theta d theta. So now therefore dE will be equal to k, that is 1 by 4 pi epsilon naught into dq. dq is lambda dy, so it will be lambda x into secant square theta d theta. Lambda x into secant square theta d theta divided by r square. R square will be, r is x sec theta, so x square secant square theta. Secant square theta will cancel, x will cancel, so it will be lambda by 4 pi epsilon naught x into d theta. So therefore this will be integral lambda by 4 pi epsilon naught, I can take it outside, by 4 pi epsilon naught x also I can take it outside, since x is a constant. X into this will be integral cos theta d theta minus theta 1 plus theta 2. So integral cos theta is sin theta, so I can say this will be lambda by 4 pi epsilon x into sin theta 1 plus sin theta 2. Similarly, the y component of the net electric field, that will be d sin theta minus theta 1 to plus theta 2. So this will be lambda by 4 pi epsilon naught x, lambda by 4 pi epsilon naught x, integral minus theta 1 to plus theta 2, integral, this will be sin theta d theta, sin theta d theta. So this will be equal to integral sin theta is minus cos theta. And d by d theta, okay. Minus lambda by 4 pi epsilon naught x into cos theta, and that will go from minus theta 1 to plus theta 2. So this will be lambda by 4 pi epsilon naught x into cos theta 1 minus cos theta 2. This is Ey. So now Here in this case, the two parts are symmetric. Parts are symmetric means it is the rod having length L and the net charge is Q. So therefore, lambda will be obviously Q by L. The net charge is distributed uniformly throughout the length of the n wire. And this is the point P here. Now this angle and this angle is the same only since it is told P is on the perpendicular bisector. Now this is A. Now therefore EY. So if this is angle theta, this will be also theta since where tan theta will be obviously equal to L by 2 by A. It's L by 2A. So therefore EY, so theta 1 and theta 2 here, that is the same, that is tan inverse of L by 2A. So therefore EY will be 0. There is no Y component, so only X component of the electric field is there. So X component of the electric field is lambda by 4 pi epsilon naught X into sine theta 1 plus sine theta. So this will be lambda, that is Q by L. So Q by L by epsilon naught. Now X, here X is A only. So not A into sine theta 1. Now tan theta, theta 1 and theta 2 are same. So I can say this will be into 2 sine theta. Now tan theta, that is by 2s. So therefore sine theta, that will be equal to, that is tan theta. Tan theta is L by 2s. Sine theta you have to find. So now sine theta is perpendicular by opposite side. Now this length, that will be root over A square plus L square by 4. So L by 2 square. So therefore sine theta, that will be equal to L by 2 divided by over A square plus L square by 4. Root over A L by 2. L by 2 by, so this will be L by root over 4A square plus L square. This will be Q by 2 pi L epsilon naught A by epsilon naught A. So sine theta is L by over 4A square plus L square. Now L will get cancelled, so it will be Q by 2 pi epsilon naught A into root over 4A square plus L square. Now A is root 3 L by 2. A is root 3 L by 2. So therefore this will be Q by 2 pi epsilon naught into 3L by 2 into root over 4 into A square, that is 3L square by 4. A is root 3L by 2, so A square will be obviously 3L square by 4 plus L square. So 4 will cancel. Now therefore the electric field at in the along the x-axis, that will be 2 and 2 will get cancelled. Q by pi epsilon naught, Q by pi epsilon naught into root 3L into by pi epsilon naught into 3L into, this is 3L square plus L square, so root over 4L square. Root over 4L square. So this is 2L. This is Q by 2 root 3 pi epsilon naught L square. Q by 2 root 3 pi epsilon naught L square. So option C is the correct answer. And here it is told charge Q is placed at one corner of the cube as shown in the figure. The flux of the electrostatic field E through the shaded area is, the flux of the electrostatic field E through the shaded area is, A charge q is placed at one cube. The flux of electrostatic field E through the shaded area is. So through this part, we have to find out. Now, here actually 1/8 part of the sphere, 1/8 part of the flux will come out. So there will be no flux through these faces. That is, through this face, through the side, through this base, and through this face, there is no flux. Only through these three faces, flux will come out, and obviously, equal flux will come out, which is at one corner. So if I keep another cube here, so it means that only 1/8 part of the charge is inside this cube. So it means q by 8 epsilon naught with the flux through these three faces, and through each face, so it will be 1/3, and so half of it will flow through, will pass through this part, half part, and half of that will pass through this part. So it will be q by 3 it's a 24 epsilon naught. Since here if we add 8 cubes, 4 in the upwards and 4 downwards, so then if we apply then the Gauss law, then we will say that the charge enclosed by epsilon naught, that is the net flux, this 8 cubes. So then that will come q by epsilon not only, but since this q is placed at the center of these 8 cubes, so through each cube, the flux through each cube, that will be obviously q by 8 epsilon naught. And so through each of these three faces, 1/3 of this flux will pass through. So that is q by 24 epsilon naught. And here they took half of this face and half of this face. So it means these two halves, if we add, then we will get one face only. So each face q by 24 epsilon naught net flux will, net electric flux will pass through. So option A is the correct answer. And here it is told two electrons each are fixed at a distance 2t. Two electrons are fixed at a distance 2t. A third charge proton is placed at the midpoint. A third charge proton placed at the midpoint, which is having charge here, plus q, and q that is E only. And here we have got minus q charge, which is where q is E. So it is placed at the midpoint is placed slightly x less, much less than t, uh, perpendicular to the line joining the two fixed charges. So these two charges are fixed. So the proton that is shifted slightly by a distance x, and then released. Then it will perform simple harmonic motion only, SHM. Then proton will execute simple harmonic motion having angular frequency. So the angular frequency omega that has been asked, angular frequency of the SHM of the uh, that has been asked. But m is the mass of the charged particle. So m is the mass of the charged particle means m is the the mass of the proton is m. So now here, if it is displaced slightly by a distance x, then the net force acting on net z will be, this will be the two forces F1 and F1, then the net force will be towards the center only F. Now F1 will be how much? F1 will be KQ1 Q2, that is KQ square by uh, this will be root x square plus d square. Now x, that means the net force, that is, if I tell this is angle theta, then F1 sine theta and F1 sine theta, these two will get cancelled out obviously, and the net force that is acting on the proton, that is obviously 2F1 cos theta, 2F1 cos theta, and where cos theta, that is obviously equal to base by hypotenuse, base by hypotenuse, that is x by square root of x square plus d square. So this will be 2 into F1, that is kq square by x square plus d square, into this is cos theta, that is x by root over x square plus d square. Therefore, the net force acting on the proton, net force on the proton, that is obviously 2k, means 2 by 4 pi epsilon naught into q square x divided by x square plus d square whole power 3 by 2. Since y it is half plus 1, that is 3 by 2. So by epsilon naught. So this is obviously q square x by epsilon naught square plus d square whole power 3 by 2. So now since x is much less than d, it is told x is much less than d, so therefore x square will be of much less than d square, and so x square plus d square is approximately equal to x square. Now x square plus d square is approximately equal to d square, since x is much less than d. So therefore the net force, that is equal to q square x by 2 pi epsilon naught by into d cube. Now this is obviously equal to mass into acceleration. Now mass into acceleration is actually omega square x. Omega square x. So therefore m omega square x, that is equal to q square. So where omega is the angular frequency of the SHM. So m omega square x, that is equal to q square x by 2 pi epsilon naught d cube. Now x will cancel, so omega square, that is equal to q square by 2 pi epsilon naught m d cube. So therefore omega will be equal to q square by 2 pi epsilon naught m d cube whole power half. Q square by 2 pi epsilon naught m d cube whole power half. So option is the correct answer. Then here it is told a cube of side A has point charges plus q located at each of its vertices except at the origin where the charge is minus q. The electric field at the center of the cube is. So at the center of the cube we have to find how much is the net electric field. Now since all the if all would have been plus q charges, then the net electric field would have been 0 only. So now if at this end, if at this vertex, if I had at the origin, if I had, so this is x-axis, this is z-axis, this is y-axis, this is the y-axis. So now if at the origin if I had plus q charge, then the net electric field would have been 0 here. So it means that here if I don't keep any charge, so it means that here only plus q charge if I keep, then this that will be acting, the electric field here that will be obviously along this point is at midpoint side A. This will be a by 2 comma a by 2 comma a by 2. That means that this would be a by 2 root 3. This length. So therefore the electric field by due to this plus q charge have been E1, that is equal to kq by r square, kq by r square, that is root 3a by 2 whole square into is I cap plus j cap plus k cap by root 3. Since it is along I cap plus j cap plus k cap by root 3. Which will be obviously kq is 4 kq by 3a square into I cap plus j cap plus k cap by root 3. So this will be the electric field which will act along this line, So it means that the electric field due to the remaining charges is opposite to that. So therefore, now if minus q charge if I keep, it means this electric field will be reversed now. So then it twice. So now the net electric field will be obviously minus of 2 E1 vector. Since why this is E1 vector into the plus q charge if I keep it at the origin. Now, so it means for the remaining plus q charges, the net electric field is opposite to that, which is minus of E1, and that is why the net electric field at the um, at the s- at the center of the cube is coming as 0 only. If I keep all charges as plus q at the vertices, at each vertex if I keep plus q charge, then the net electric field at the center will be 0 only. So it means that due to all the remaining plus q charges, the electric field at this center is minus of E1, and so due to plus q charge it is E1. So therefore they are equal and opposite, they will get cancelled. So now instead of plus q, if I keep minus q charge, so this electric field E1 will be now reversed. So this will come minus of E1 again. Now these two electric fields, if I add them, then I will get minus of 2 E1. So therefore the net electric field which we will get in this case, that will be minus of 2 E1. So it will be minus of 2 into this 4kq by 3a square into I cap plus j cap plus k cap by root 3. It will be minus 8 by 3 into q by 4 pi epsilon naught a square into root 3 into I cap plus j cap plus, or I can say x cap plus y cap plus j cap plus z cap. So 4 to the 8. So this will be obviously minus 2q by 3 root 3 pi epsilon naught a square into x cap plus y cap plus z cap. Minus of 2 cube by 3 root 3 pi epsilon naught a square into x cap plus y cap plus z cap. So option D is the correct answer. Then here it is told a particle of mass 1 milligram, 1 milligram, which is 10 power minus 3 gram, and charge q is lying at the midpoint of stationary particles at a distance 2 meter when each is carrying same charge q. A particle of mass 1 milligram and charge q is lying at the midpoint. It's lying at the midpoint of two stationary particles. Midpoint of two stationary particles lying at the midpoint of two stationary particles. So they are carrying same charge q, kept at a distance of 2 meter. So they are kept at a distance of meter. And this charge q is kept at the midpoint. If the free charged particle is displaced from its equilibrium position through a distance x, the particle executes SHM, its angular frequency of oscillation will be. So it is slightly displaced by a length x. So then it will execute SHM where x is much less than 1. Then the angular frequency of oscillation will be this much meter per second. If q square equal to 10 coulomb square. So here it is told that q square equal to 10 coulomb square. This has been given. Then we have to find the angular frequency omega of the SHM. So now has been displaced by a distance x. So now this is charge q. This is also charge q. This is also charge q. This is x. Now this has been displaced by a length x. One meter length. This is, since this is the midpoint. Midpoint. So if it comes here, then the net force that it will be exerted, that will be the net force, that is F1 minus F2, F1 minus F2. F1 is the repulsion due to this charge q and F2 is the repulsion due to this charge q. Now this length will be obviously 1 plus x now, and this is obviously 1 minus x. So F1 be actually kq square by 1 minus x whole square. Minus this will be kq square by 1 plus x whole square. Kq square, so q square by 4 pi epsilon naught into, this is 1 by 1 minus x square minus 1 by 1 plus x whole square. So this will be q square by 4 pi epsilon naught into, this will be 1 plus x whole square minus of 1 minus x whole square by 1 minus x square whole square. Now a plus b whole square minus a minus b whole square, we know that is equal to 4ab. So this is q square by 4 pi epsilon naught into, now 1 is obviously, x is much less than 1. So it means that x square also will be much less than 1. So 1 minus x square is approximately equal to 1. So this I can write 1. So this is equal to 4ab, 4 into x. Cancel. So this is q square x by pi epsilon naught. So this is the net force. Now this net force is acting towards the center, which is the equilibrium position of the SHM. The equilibrium position of the SHM is at the midpoint only, which is the equilibrium position. Now the net force that is acting towards the center, that is equal to mass into acceleration, which is m omega square x. So therefore m omega square x, that is equal to q square x by pi epsilon naught. So therefore x will cancel. So now therefore omega square will be q by pi m epsilon. Therefore the angular frequency of this HM omega will be equal to q by q square by pi epsilon naught m whole half. So square root of that. So now q square has been told 10 and pi epsilon naught for we know that 1 by 4 pi epsilon naught, that is equal to 9 into 10 power 9. So now it means 1 by pi epsilon naught, that will be 9 into 4, 4 nines are 36 into 10 power 9. So this is into 36 into 10 power 9 divided by m, that is mass of 1 milligram. 1 milligram, it means 10 power minus, okay, 10 power minus 3 gram, it means it is 10 power minus 6 kg. It's 10 power minus 6 kg. So whole power half. So this will be 10 power 10. This is 36 into 10 power 16 whole power half. So this is 6 is a 36. So 6 into 10 power 8 radian per second. This is 6 into 10 power 8 radian per second. And 1 milligram. So it is 10 power minus 6 kg. This much radian per second. So it will be obviously 600 into 10, 600 into 10, so, or I can say 6000 into 10 power 5 radian per second. Okay, so 6000 into 10 power 5 radian per second. So the answer will be 6000 here. 6000 10 power 5 radian per second. Since the answer is 6 into 10 power 8 radian per second. Okay, so here it is told the total charge enclosed in an incremental volume. Incremental volume means dV, or I can say delta V. The that is 2 into 10 power minus 9 meter cube, located at the origin, is dash nano coulomb if electric flux density of its field is found as electric flux density of its field is found as this electric flux density. It means it is means the electric field only. Electric field is e power minus x sine y I cap minus e power minus x cos y j cap. Electric flux, we know it is d phi, that is e dot ds, e dot da I can say. So it means the electric flux density, that is simply the electric field only, plus 2z k cap coulomb per meter square. Coulomb per meter square. Okay, electric flux density Electric flux density of its field. Coulomb per meter square means it is sigma. Means that it is sigma. Sigma is charge per unit area. Sigma is charge per unit area. It means dq by dA. That is this. Now the total charge in this incremental volume that has been asked. The total charge that is equal to sigma into dA. Now electric flux density. Electric flux density D, that is epsilon naught times E. Epsilon naught times E. Now the net charge that is enclosed here. Volume. So now you know that E dot ds, E dot dA, that is equal to d phi, which is equal to d cube by epsilon naught. Charge enclosed by epsilon naught. Is dq, that is equal to epsilon naught times E in dot dA. It means it is d dot dA. Incremental volume. So incremental volume actually EV, that is Actually, we can find the volume charge density. We can find volume charge density, that is equal to del dot, since we know that in closed integral E dot dA, that is equal to charge enclosed Q enclosed by epsilon naught. So this also we can write integral uh, del dot E into dV, del dot E into dV, where V is the volume integral we have to do. Here surface integral has been converted into volume integral, which is equal to Q enclosed by epsilon naught. So therefore del dot E I can say that is equal to actually um, rho by epsilon naught. So therefore rho, which is the volume charge density, that we can say it is del dot uh, epsilon naught times del dot E, or I can say del dot epsilon naught E, del dot epsilon naught E. Now epsilon naught E is nothing but D, which has been told here. D is the electric flux density. So now therefore rho, that will be equal to del dot del dot D, del, del dot D, where D is the electric flux density of this field, which is dou by dou x I cap plus dou by dou y j cap plus dou by dou z k cap. So therefore now rho, which is the mm, charge density, that is dou by dou x I cap plus dou by dou y j cap plus dou by dou z k cap, dot product with D, that is e power minus x sin y I cap minus e power minus x cos y j cap plus 2z k cap. So this will be dou by dou x. So it will be dou by dou x of e power minus x sin y plus dou by dou y of minus e power minus x cos y plus dou by dou z of z. So here x is a variable, so it will be minus e power minus x sin y. And here y is the variable, x is the constant, so it will be plus e power minus x sin y, since d by dy of cos y is minus sin y. And here z is the variable, so it is plus 2. So this is rho. So now therefore the volume charge density, rho is the volume charge density, so the volume charge density at the origin that we find at the origin, it means at x equal to 0, at 0 comma 0 comma 0, it means that we find. So e, this is minus e power 0 into sine 0 plus e power minus 0 into sine 0 plus 2. So sine 0 is 0, so it will be 2 per meter cube. So now therefore the net charge dq the origin at the origin that we would find for the incremental volume dv. So therefore the total of dv, so rho is 2 coulomb per meter cube into dv, that is 2 into 10 power minus 9 meter cube. So this will be 4 meter cube will get cancelled, 10 power minus 9 coulomb, which is 4 nano coulomb. So 4 nano coulomb. And here it has been told body having specific charge 8 microcoulomb per gram. A body having specific charge 8 microcoulomb per gram, which is charged by mass. Charge by mass of that body is 8 into 10 power minus 6 coulomb per gram. So coulomb by 10 power minus 3 kg. 10 power uh, 1 gram is 10 power minus 3 kg. So it is 8 into 10 power minus 3 coulomb per kg. Is resting on a frictionless plane at a distance 10 centimeter from the wall. It is located at a distance of 10 centimeter from the wall. This is the wall shown in the figure. It starts moving towards the wall when a uniform electric field, the electric field 100 per meter is applied horizontally towards the wall. If the collision of the body with the wall is perfectly elastic, then the time period of the motion will be time period of the oscillation. So it will perform oscillation. First it will collide and then again it will come back and then again it will collide like this. So it starts from here. It starts from here. So from here it will start. So the net force acting that is obviously QE. Force acting it is equal to QE and the acceleration that is QE by M. It's placed at a distance of 10 centimeter from the wall. So acceleration will be 8 into 10 power minus 3 into electric field that is 100. So that is 0.8 meter per second square. So here initial velocity is 0 here initially. Then with what velocity it will hit the wall that we can find out. And since the collision is elastic, so after collision it will again gain the same velocity v but in the opposite direction. The opposite direction. So v will be equal to actually u plus 8 okay, v square equal to u square plus 2. So v square will be equal to 2a into s, 2a into s. And here s is 10 centimeter, which is 0.1 meters. So v square is 2 into a 0.8 into 0.1, which is 16, so 0.16. So therefore v will be equal to 0.4 meter per second. Then again it will gain 0.4 meter per second velocity, and then it will have a retardation of 0.8 meter per second square. Then again it will come to rest here. Again it will come to rest at after how much time that we can find out. After how much length it will come to rest that we can find out also. So let's say so v equal to u plus at, so 0 plus a into t. So t we can find out how much time it takes to go from here to here. The time it takes, let's say t1. So t1 will be equal to v by a, so 0.4 by 0.8, which is half second. So half second it will come here, and from here to here again it will go here also. Final velocity will come 0, so 0 will be equal to v minus a into t2. Let's say it takes time t2 to reach here. So T2 will be again V by A, which is 0.4 by 0.8, which is half second. So it means that it comes from rest. It will start from here, and it will gain the velocity 0.4 meter per second when it will reach the wall, and then after hitting the wall again it will come to rest here after half second. So half second plus half second, so that is 1 second. So 1 second is the time period of this motion. So the same thing will happen again and again. So the time period of the motion is 1 second. So then here it is told an infinite number of point charges carrying 1 coulomb charge are placed along the y-axis at y equal to 1 meter. At y equal to 1 meter it is kept, and at y equal to 2 meter again the charge q is kept. At y equal to 4 meters, so this is y equal to 3, this is y equal to 4. At y equal to 4 meter again one charge q is kept, and then again at y equal to 8 one charge is kept. Then, and the charges, their value is 1 micro coulomb 10 power minus 6 coulomb. The total force on a 1 coulomb point charge, 1 coulomb point charge, capital Q, 1 coulomb kept at the placed at the origin 0, 0 is the net force, that is x into 10 power 3 Newton. The value of x to the nearest integer is the value of x to the nearest integer we will find. So, and 1 by 4 pi epsilon naught value has been told us 9 into 10 power 9 Newton meter square per coulomb square. So then the total force we have to find. So the net force that will be equal to F1 due to the first charge which is kept at 1 meter, then the force due to the second charge which is kept at 2 meters, then the force due to the third charge which is kept at 4 meters. So all these forces we have to add. So this will be K q1 q2 by r square, that is 1 square, plus this is K q1 q2 by 2 square, plus this is K q1 q2 by 4 square, plus this will be K q1 q2 by 8 square, and so on till infinity. So from here we can see that this is q by 4 by epsilon naught into, I can write this is 1 plus 1 by 4 to the 4, 1 by 4 plus 1 by 16 plus 1 by 64 plus this is, and so on. So here we can see that it is an infinite GP. Infinite GP, this is having with common ratio R, that is 1 by 4. Common ratio is 1 by 4. So therefore, as we know that sum of an infinite GP is given as A by 1 minus R, where A is the first term. If you have A plus AR square plus AR cube and so on till infinity, where mod R is much less than, where if mod R is less than 1, then this sum of infinite terms is given as approximately A by 1 minus R. So A by, so therefore here the sum of these infinite terms, which is 1 plus 1 by 4 plus 1 by 8, no, 1 by 16 plus 1 by 64 and so on till infinity, that will be equal to A, which is 1 by 1 minus R, 1 by 4. So this is 1 by 3 by 4, that is 4 by 3. So this is 4 by 3. So therefore the net force acting on this 1 coulomb point charge, that will be equal to q by 4 pi epsilon 3. So 4 get cancelled. So it is q by q by 3 pi epsilon naught. I can say q by 4 pi epsilon naught, yeah, into 4 by 3 only. Q into q. So q is small q is 1 microcoulomb, so 10 power minus 6 coulomb. Q is 1 coulomb divided by into 4 by 3. 4 by 3 into 1 by 4 pi epsilon naught is 9 into 10 power 9. So this much. So 3 3s are 9. So 3 4s are 12. 12 into 10 power 3 Newton. So therefore, the value of x is 12. Is the answer. Then here it is. The electric field in a region is given by E vector that is equal to 2 by 5 E naught I cap 3 by 5 E naught J cap, where E naught that is given as 4 into 10 power 3 Newton per coulomb. 10 power 3 Newton per coulomb. Flux of this field through a rectangular surface area 0.4 meter square parallel to the y-z plane is electric field in a region is given by this, and then E naught this the flux of this field through a rectangular surface area. Okay. Suppose this is x and y, this is z. Okay. X-axis, y-axis, z-axis. So then y-z plane means this plane. A rectangular surface which is surface area. Its surface area is 0.4 meter square, and it is parallel to the y-z plane. So it means that its normal vector n cap that is same as the I cap. N cap is I cap. So therefore now the net flux, the electric flux, that will be obviously E dot A. E dot A. Now here the area vector, that is the magnitude of the area into n cap. So that is actually A I cap. So that is 0.4 meter square I cap. So now it means that will be 2 by 5 E naught I cap plus 3 by 5 E naught J cap. Its dot product with 0.4 meter square I cap. So it means that with I cap and I cap only we have to multiply, since J cap dot I cap is 0 and I cap dot I cap is so therefore it will be 2 by 5 E naught into 0.4 meter square. So phi E electric flux, that will be 2 by 5 E naught, that is 4 into 10 power 3 into 0.4 Newton meter square per coulomb. 2 by 5 means 0.4 only. 5 4s are 20, 0.4. So 4 4s are 16, 1.6 into 0.4 into 10 power 3 Newton meter square per coulomb. So this will be 16 into 4 into 10. 16 4 is 64, 640 Newton square per coulomb. So 640 is the answer. And here it is told 27 similar drops of mercury are maintained. 27 similar drops of mercury, so they are having same charge and same radius, and they are maintained at 10 volt each. So therefore I can say kq by r, that is equal to 10 volt. So then all these spherical drops, they will combine to form a single big drop having radius r and charge q. The potential energy of the bigger drop is dash times of that of the smaller drop. Now KQ by R is 10 volts. Now therefore the potential energy, now they are kept at the same potential. So potential and potential energy is not the same. Now we know that potential energy potential energy of a charged sphere, of a uniform charged sphere, that is given as kq square by 2r. Kq square by 2r. So now we can say that q, that is equal to 27q by the law of conservation of charge, since charge can't be lost, and volume also will be same, 4 by 3 pi r cube, that will be equal to 27 times 4 by 3 pi small r. So therefore we can say r will be equal to 3r. So therefore here the potential energy U1, let's say this is U. So U1, the potential energy of each small drop, that is obviously kq square by r, and potential energy of the large drop, that is kq square by 2r. So U1 is kq square by 2r. This is k capital Q square by 2r. So k into 27q whole square by 2 into 3r. So this will be k into 27 into 27 into q square by 2r into 3. So 3 9s are 27. So this is 27 into 9 times kq square by 2r. So it is actually 7 9s. 7 9s are 63, 2 9s are 18, 24, 243 times. And if we take only the potential, then it will be kq by r, and that will be obviously k into 27q by 3r. So this is 3 9s are 27, which is 9 times the potential of the each small drop. So it means here we have to use potential energy only. So the answer will be 243. So the potential energy of the large drop, that is 243 times the potential energy of the small drop, means U is equal to 243 times U1. So the answer is 243. And here it is told that two identical conducting spheres with negligible volume. Two identical conducting spheres with negligible volume. Identical conducting spheres of negligible volume have charges 2.1 nanocoulomb and minus 0.1 nanocoulomb charges respectively. So their volume is negligible. They are brought in contact and then separated by a distance of 0.5 meters. So when they are brought in contact, then so this is having charge. Okay. So then they will have the electrostatic force acting in between the two spheres is dash into 10 power minus 9. So they have negligible volume. It means we can consider them as almost point sized. So one is having 2.1 nanocoulomb, one is having minus 0.1 nanocoulomb. So after they are brought in contact, then they will carry the same charges Q and Q. So it means 2Q, that is equal to 2.1 minus 0.1 nanocoulomb. So it means that Q is equal to 1 nanocoulomb now, since it is 2 by 2. So when they are separated by a distance of 0.5 meters, then the electrostatic force of repulsion acting in between them. So that force will be kq square by r square. So here r is 0.5 meter and 1 by 4 pi epsilon naught into q square, that is nanocoulomb, means 10 power minus 9 coulomb. So 10 power minus 9 whole square divided by r square. R is 0.5 whole square. This will be 1 by 4 pi epsilon naught, means 9 into 10 power 9 into this will be 10 power minus 18 divided by this is 0.5, so half half whole square, that is 1 by 4. So 4 nines are 36, 36 into 10 power minus 9 Newton. So the force is 36 into 10 power minus 9 Newton. So 36 is the answer. And it is 12 small spheres, each of mass 10 milligram. Two small spheres, each of mass 10 milligram, hence it is 10 power minus 5 kg, are suspended from a point. They are suspended from a point by threads. Suspended from a point by threads of length L. L is 0.5 meters long. The spheres have got mass m, and they repel each other to a distance of 0.2 meters. So this length is 0.2 meters. Let's call this as x. X is 0.2. The charge on each of them, the charge on each of the sphere is q. Charge on each of the sphere is q. So q is a by 21 into 10 power minus 8 coulomb. So then a we have to find out, and g we have to take it as 10. So here what will happen? The mg will act downwards, and then the e- electrostatic force will act, which is q times kq square by x square. And this is the tension force. This is angle theta. Then this will be t sine theta. This is t cos theta. This is L. L is 0.5, means half. X is 0.2, so this is 0.5 and this is 0.1 meter. So angle theta we can find out. So therefore now say that t sine theta, that is equal to kq square by x square, and t cos theta, that is equal to mg. So if we divide these two, then we will get tan theta, that is equal to kq square by x square mg. Now therefore tan theta, so now tan theta, that is equal, no, from here we can say sine theta is 1 by 5. This is 0. Meter 0.1 by 0.5, opposite side by hypotenuse. So cos theta, that will be equal to square root of 1 minus 1 by 25, that is 24 by 25. So root 24 is 2 root 6 by 5. So tan theta is 1 by root 6. Means that 1 by 2 root 6, that is equal to k square q square by 4 pi epsilon naught x square, that is 0.2 whole square into q. I have to find out. Q I have to find out. No, yeah, q I have to find out. Okay. So if I can find q, then I can find out a also. M mass is 10 milligrams of 10 power minus 5 and G is 10. So now therefore Q square, that is equal to pi epsilon naught into 0.04 into 10 power minus 4 divided by 2 root 6 to 0.02. So this is Q square will be equal to, this is 2 into 10 power minus 6 by root 6 into 1 by 9 into 10 power 9. So Q square I can write, this is root 6 I can write root 2 into root 3. So this is over 2 by 3 into 1 by 9 into 10 power minus 6 minus 9, that is minus 50. You can say Q square, that is 10 root 2 by 9 root 3, 10 by 9 root 3 into 10 power minus 16. So therefore Q will be equal to something like this, root over, okay, 21. Okay. They are charged, equally charged, and repel each other to a distance of 2 meter. We take this is 0.2, then sine theta will be 2 by 5, then cos theta will be 5 minus root 21 by 25. So it is approximately 1 only, 1 into 10 power minus 8. So it means therefore A by 21 is approximately 1. So therefore A will be approximately 20, A will be 21. We have to actually take the root of this. You will be root over 10 by 9, 3, which is approximately 1 only. This is 10 power minus 8. Now this is root over 1 is approximately 1 only. So this will be 21. So the value of A is 21. Then here it is told the electric field the electric field in a region is given by E equal to 3 by 5 F E naught I cap plus 4 by 5 E naught J cap Newton per coulomb. Ratio of flux of reported field through the rectangular surface of area which is parallel to the YZ plane. This is x-axis, this is y-axis, this is z-axis. So this plane is having area 0 meter square, and since it is parallel to the YZ plane, so the unit vector along the normal is I cap. That of the surface of area 0.3 meter square, which is parallel to the XZ plane, so its n cap is its unit vector along the normal is j cap, is A is to B. So the ratio of these two fluxes phi 1 by phi 2, phi 1 by phi 2, that is A by B, and where A is equal to A is how much? We have to find. So phi 1, that is obviously E dot A, so it is 3 by 5 E naught into 0. Since why only the X component of the electric field will provide the flux here, and here for this one the Y component of the electric field will provide the flux. So phi will be obviously 4 by 5 E naught into 0.3. So therefore phi 1 by phi 2, that will be 3 by 5. Yes. So 5 6 are 30. So 0.6 into 0.2 E naught, and this is 5 8 are 40. So 0.8 into 0.3 E naught. So this will be equal to actually 2 6 are 12. So 0.12 E naught by 3 8 7 20. So 0.24 E naught. So E naught will cancel. So 12 by 24 it is 1 by 2. So therefore A is to B is 1 is to 2. So therefore the value of A is 1. Here it is told that 512 identical drops of mercury are charged. 512 drops of mercury are charged to a potential V1 of 2 volts. The drops are then joined to form a single large drop. Then the potential of this drop V naught V2, that will be how much? So now V2, that will be obviously equal to KQ by R, where R is the radius and Q is the charge of this large sphere, and small q and small r are the radius, are the charge and radius of each of the 512 identical drops. So then we can say Q will be equal to 512 Q by law of conservation of charge, and then the net volume will be the same. So 4 by 3 pi r cube, that will be equal to 512 into 4 by 3 pi small r cube. So therefore r cube, that is equal to 512 r cube. So therefore r will be equal to 512, that is, I can say that is 256 into, so it is actually 1024 by 2. It means 2 power 10 by 2, that is 2 power 9. So the cube root of this, cube root of 512 power 1 by 3 is 2 power 9 power 1 by 3, which is 2 power 3, which is 8. So r equal to 8r. So therefore V2, that will be equal to K in, so this KQ by R, that is 2 volts. So therefore K into capital Q, that is 512 Q by 8 R, that will be equal to 512 by 8 into KQ by R, which is 8 6 are 48, 4 8 are 32. So 64 times 2 volts, that is, for the 8 to 6 are 12, 128 volts. So the potential of this large drop will be 128 volts. Then here it is told that a point charge of plus 12 microcoulomb microcoulomb is at a distance, this is plus 12 microcoulomb is at a distance of 6 centimeter vertically above the center of a square of side 12 centimeter as shown in the figure. Side 12 centimeter as shown in the figure. The magnitude of electric flux of the center of a square side 12 centimeter as shown in the figure. The magnitude of electric flux to the square will be. So now it means that if we take a cube if we take having side length 12 centimeter, then this charge which is kept at a distance of 6 centimeter above the base of this cube, it means that the charge is placed at the center of the cube. So it means if we by Gauss law we can say that the net electric flux that through the cube, that will be equal to the net charge enclosed by epsilon naught. So therefore then the net flux through all these 6 faces will be the same only. So I can say through each phase the flux through each phase, if the flux is phi, then the net flux through the cube, that will be equal to 6 times the flux through each phase. The flux through the entire cube is 6 times the flux through each phase. So it means that is equal to q by epsilon. Or since the charge enclosed is q. So it means the net flux through each phase, that will be equal to q by 6 epsilon naught. So this only will be the answer, since why this square is nothing but the is like the base of the cube, is like the base of this cube of side 12 centimeter. So it is the uh, like a base of this cube having the side 12 centimeter, where the charge q, which is 12 microcoulomb, where this charge 12 microcoulomb is placed at the center of that cube. Is at the center of that cube. Center of that cube. So therefore the magnitude of the electric flux through this square face, that will be equal to q, that is 12 microcoulomb, 12 into 10 power minus 6 by 6 epsilon naught. Now epsilon naught is 8.854 into 10 power minus 12. So this much Newton meter square per coulomb. 6 2s are 12. So it is 2 by okay, side length is 12 centimeter, distance okay is 12 microcoulomb. This will be actually, I can say 2 by 8.854 into 10 power 6. So it means I can say 2000 by 0.854 into 10 power 3 Newton meter square per coulomb. So it means we have to find the answer of 2000 by 8.854 into 10 power 3. So this value only will be the answer. So 2000 by 8.854, that is approximately 2000 divided by 8.8. That is equal to 225.9 approx, or I can say approximately 226. So the magnitude of the electric flux to the square will be approximately 226 into 10 power 3 Newton meter square per coulomb. So 226 is the answer. So hope all of you have understood the solutions of all these questions based on the previous year JEE Mains exam on the chapter Electrostatics. Still, any doubts if you have, please write that in the comments, and please install our Sapience education application also, where we shall upload some important questions which are based on the previous year exam, which will be obviously helpful for your JEE Mains exam. So thank you everyone. Bye.